All right, so this is simply an application of exactly the same thing we did yesterday. But what if you have two different equations? Right, I'm going to draw a graph that does that. And I'm going to draw a graph that does that. Okay, and I want us to find this. Does anyone want to make a prediction about how we're going to do it? Okay, so the thing that we need to do is find our boundaries, right? We need to find our top and our bottom limits. So we need to know that, and we need to know that. Now, clearly, I have not given you enough information to do that yet, but let's do that in a second. I want you to tell me generally how you think we might be able to find the shaded area.
Well, the area of the thing minus the area under the.
Yeah, absolutely. So there are two ways we can do this. We can call this. So, I mean, we're going to use these two bits. Let me just mark that in because that's easier to see. We can either subtract a trapezium, right? The area of a trapezium from this area, because those are our boundaries, or we can integrate this and subtract it from the integration of this, right? Because that gives us the area under this bit. So it doesn't matter. I'm going to show you that both of them get you the exact same answer. But the first thing I'm going to do is write our two equations. So
it's just a triangle or rectangle.
It is, yeah, exactly, yes. But there are two ways you can do that. I'm going to show you how to do both of them. Plus 8x plus 5. And the other one is going to be x plus, whoops. Yeah, x plus 1. Okay, so these are my two equations, which makes this what? Makes that 1. Do we need that information? Nah, who cares, right? So what I need to do, though, is find out what these 2 points are. That's really important. So how do I do that? Yeah. So we're just going to use substitution, right? These are simultaneous equations. I'm going to put them together. So this is 0 equals negative x squared plus 7x. Hang on a second. I think, you know what? That's not going to work because that should be a minus sign. Otherwise, it won't work. Minus 5, so this is minus 6. Okay, so I need to take out my negative, otherwise I can't factorize. So what do I get? What are my two numbers? Minus 6 minus 1, which means x is going to be 6 and 1. So this is 1, this is 6, right? 6 and 1. So those are my boundaries. That's how I'm going to integrate. Okay? So let's do that in another color. So we're going to integrate from 0 to 6, and we're going to integrate this equation. So negative x squared plus 8x minus 5 with respect to x. Sorry, I don't know why I wrote that. Very good point. That should be 1. Okay, so I'm going to I'm going to integrate with this equation. And then I'm going to subtract the trapezium. Yeah? So what do I get if I integrate this? So negative x cubed over 3. Yeah? Now what? Plus 4x squared minus 5x. Good. And then my trapezium, what's the area of... Actually, let's not do that yet. Because this bit we don't want.
The points are 1.
Right? So 1 and 6. So this...
1, 2, and 6, 7 are the points.
Oh, if you put that in there, yes. So we need to do that in a second, don't we? Yeah. Yep, you did. So, okay, I am going to find out the area now. So I'm going to substitute in 6. So I've got negative 6 cubed over 3 plus 4, 6 squared minus 5, 6. And I need to subtract my ones. So I've got negative 1 cubed over 3 plus 4, 1, let's put brackets around that, squared minus 5, 1. And then once I've got that, you know what, I'm just going to ignore the trapezium bit for now because I don't have enough room. Let's do that in a second. All right, so I have not written it all out, but if you type all of that into a calculator, you should get 20 and 5/6 units squared. But let's do the trapezium bit as well.
Area.
That's the area. So that is the area between the curve all the way down to the x-axis, right? But the problem is we don't want this bit, so we have to subtract this bit. Okay, so I've just worked out all of this.
The entire thing of that curve.
Between the curve and the x-axis, between 1 and 6. So now I'm going to get rid of this trapezium bit, right? So let's do it underneath it. Let's do this minus 20 and 5/6. Okay, John, tell me what you just said the coordinates were for these. 1, 2, and 6, 7, because it's just x plus 1, isn't it?
Yeah.
So 6, 7. So those are our two coordinates. That gives us the height of our trapezium, which is good because a trapezium, oh, go back up. A trapezium is half a plus b times by h, right? So that's going to be half. A plus b is these two lengths because these are the ones that are different heights. So we've got 2 plus 7. So you can think of this trapezium as being sideways, really, right? This is a sideways trapezium where these are the two lengths that are different. So the height is 5, isn't it? Right? It's this bit here. Yeah, good. Okay, so then when we go down here, we are subtracting half plus 9 is 3 times 5 is 15. Yeah? So then all together, ooh. What? 2 plus 7 is 9. Half of 9 is 4.5. Why did I say it was 3? Okay, it's not 15. 22 and a half. All right, so am I going to, this is right, I'm subtracting them or am I adding them? Yeah, I'm subtracting them. Okay, so, oh, you know what? That's not the right answer. That's the whole answer. I've done something stupid. I just copied it out of the book. This is 20 and 5/6, which means I have to add 22 and a half. Oh my gosh, I can't be bothered doing that. Did someone type that into a calculator? This is something. That plus 22 and a half is this. Sorry, I wrote down the wrong thing. All right, so this is whatever that bit is. All right. There is another way you can do this, right? So like I said before, the other method of doing this is instead of subtracting the trapezium, you subtract the integral of this between 1 and 6, right? So the other way of doing that is to then say, I am going to minus the derivative of this, sorry, the integral of this. So you can, it does. That's exactly what it does. So I don't really care which way you do it. If you're subtracting the trapezium area, that's probably easier, frankly, because you don't have to do extra integration. We should all know a trapezium. This is a sideways one. I think that's the most common method of doing, or it's one minus the other anyway. But let's, for argument's sake, do an example. Yeah, let's just do that. Okay. If you, did I already save that? I don't know. Let's do it the other way. Actually, I really did not need to undo all of that. How much of this do I need to undo? Just the red bit, really. All right, so we are now, instead, I'm not going to do the trapezium bit, but we are going to subtract the derivative of the other bit, right? So we need to subtract between 6 and 1, x plus 1 with respect to dx. So what's the derivative, the integral of this? Right, half x squared plus x. And then you are going to, oh, geez, let's go back down here. So that means we're going to subtract this as a 6. So half 6 squared plus 6 minus half 1 squared plus 1. And you will get the exact same answer. This is the same thing. So it doesn't matter which way you do it. You can subtract one integral from another, or you can just say, hey, that's trapezium. I'm going to subtract the trapezium at the end. Okay? Some of us are not looking excited about all of this. All right, we are going to do some work now. I can't remember, did I? Yeah, I did just say that. All right, that'll do.